Hello dear students, so let's start with the discussion of physics paper 2 JEE Advanced 2022 and I'm going to take from question number 1 to 5. So without any delay, let's start with the discussion of question number 1. As you can see, they have given a force people, initial position of the particle they have mentioned, initial velocity of the particle they have mentioned, and they are saying that at when z coordinate of the particle is 0.5 meter, they wanted to ask what's the value of x times of Vy minus y times of Vx. And as you can see people, force is acting only in x and y direction, then there won't be any kind of change in velocity in z direction people. So what is the initial velocity in z, that is 2 by pi, that's going to be the same. Yes, velocity in x, y would be changing. And yes, particles position will be changing in all three. One thing I wanted to make you sure that, can you see force can be written as, here force is k minus k times of position. Can you see that xi cap plus yg cap is generally the position? Yes sir. It means is force and position, are they parallel always? Yes sir. If force and position are parallel, can I say torque of this force about origin would be 0? 100% sir. If torque of the force about the origin is 0, can I say initial angular momentum of the particle is final angular momentum of the particle? What is the initial angular momentum people? The formula of angular momentum, I guess you may know that. It is m times of Ri cross Vi would be m times of Rf cross Vf. That is m times of R cross V is the m R cross V is the formula for angular momentum. So for initial, that's m times of initial position cross of initial velocity, m times of final position cross of final velocity. Let's write the values. I cap, j cap, k cap, which would be equals to I cap, j cap, k cap of final hence. And yes, mass and mass are definitely cancelled. Initial position people. So initial position they have given us 1 by root 2 and 1 by root 2 and root 2 and 0. Great sir. What is the initial velocity? So the initial velocity is this, minus root 2 minus root 2 and 2 by pi. So final position people I do not know, so let it be x, y, and the final position of z they have given us 0.5. And as you can see, the final velocity I do not know, Vx, Vy, and velocity in z would not be changing because there is no force in z. These value will be equal. I guess all of you can really do this one, basic math. So let me just write the statement to you. That is I times of root 2 times of 2, so 2 root 2 by pi minus of 0 minus of j cap. So j cap, if you see people, it will be 1 by root 2. So root 2 by pi minus of 0 plus k cap. When you k cap will be taking, you will be multiplying that. So that will be coming 1 plus of 2. That will be equals to I cap. I cap if you take over here, that is y times of, so 2y by pi, 2y by pi times of 0.5 into Vy into 0.5 minus of j cap, that is 2x by pi minus of, it will be 2x by 0.5 Vx 0.5 plus of k cap. What's the k cap coming people? If you see the k cap, x Vy minus y Vx. So that's the statement people. There again you see x Vy minus y Vx is coming, and that's what they have asked over here. I guess it's clear to all students. So if you just proceed it further, let me just tell you the direct answer for this one. If you just solve it further people, x Vy minus y Vx is coming out to be 3. So x times of Vy minus y times of Vx is coming out equals to 3 people. I hope so the question is clear to all. Basic calculation of maths. Let's proceed with the next question. A very easy question of modern physics, I see. So basic, you can just use the charge conservation as well as the mass conservation in this question. You can see in radioactive decay chain reaction, thorium decays into polonium. Great sir, polonium is happening when the thorium is getting decayed, and some alpha particles and beta minus particles are emitted as well. So first of all, what are the ratios of, they have asked the ratio of the number of alpha to number of beta particles. Okay, let's assume, let's say the total number of alpha particles, let's assume is small n, and total number of beta minus particles, let's say small m. I've assumed it. Okay, firstly let's use the mass conservation. If you use the mass conservation people, initial total mass is 230 of thorium. On the right side we are getting polonium is 214 as well as alpha particles. So n times of 4. So why n times of 4? Because every alpha particle's mass is 4u, I know that. So definitely n times, if n numbers I have assumed, that will be n times of 4. Will there be any mass of beta minus particle? No sir, it won't be having mass. So definitely I won't be reducing the beta minus over the mass conservation. And if you solve it further, it will be going as 16 by 4. So n is coming out to be 4 people. Okay, remember this, n is coming out to be 4. Next thing, charge conservation. So let's use the charge conservation over here. In charge conservation people, initial charges you can see 90 plus 90, that is depending on atomic number. On the right side, when thorium is decaying into polonium, you can see that on the right side 84 positive charges we have. Every alpha particle, how much charge it carries? Sir, plus 2. Great. So plus n times of plus 2 charge, and every beta minus particle is having minus 1 charge, sir. So minus of m times of every beta particle's charge contribution. So do I know value n? And you substitute n equal to 4 over there, and m is coming to be 84 plus 4, 4 to 8. So this will be coming out to be 92 minus 90, and m is coming out to be 2. So they have asked n is to m ratio. So n is to m ratio you can see is 2. N is to m ratio would be coming as 4 by 2, that is 2. You can see very basic question from modern physics they have asked. Let's proceed with the next question, that is question number 3, people. This interesting question. If you really see the JEE posture also, in JEE posture they have asked this kind of question. So for advanced perspective, this would become easy question, people. They have guessed that here R1, R2 are mentioned. So R1 I do not know, they have mentioned this as X ohm resistance. R2 they have mentioned as people 1 ohm resistance, you can see over here. Okay. And connected to a wire AB of uniform resistivity, you can see a wire AB of uniform resistivity, AB they have connected. The radius of the wire varies least. So here the radius is 0.2 millimeter and getting increased to 1 millimeter at B. A galvanometer is connected to the center of wire 50 centimeter. It means the complete length of the wire is 100. Shows zero deflection when A and B are connected to battery. So when it is showing zero deflection, it means there's a definite, what is happening? Balance reached from which conditions are achieved, people. So this is to this ratio would be equal to this is to this ratio. So this resistance and this resistance, let's consider this as R2. R2 is this, so let it be R3 and R4, people. What are the values of R3, R4? For that I have to actually make the diagram for wire. Its radius is increasing, people. So you have to assume an element. If you assume an element, people, at x distance of dx thickness, we have to find the radius. What shall be the radius? This small r. This is the radius at A point, and that's the radius at B point, people. By similarity of triangle, can I write RB minus RA by total length, that is 100, is equals to R minus RA. Can you see this triangle if you draw? This triangle, can you see this triangle? And this triangle is similar. So RB minus RA would be this distance, people, divided by length, equals to this minus this, that is this by base, that is R minus of RA by base. I do not know what this base is. Let it be x, people. Okay, so RB is, they have given 1 millimeter minus 0.2 by 100 is equals to R minus 0.2 by x. If I proceed further, 0.8, so it will be 8 by 1000. 8x by 1000 equals to R minus 0.2. So your x and R small r is related now. And if you differentiate both sides, get the relation also. So 8 by 1000 dx is equals to dr. That's the relation between dx and dr. We got it. I'm going to use it further. Now, if you really want to see that, what's the resistance for left element and right element? So lengths are equal. So can I say R3? I guess R3 by R4, or can I say R1 by R2 is to R3 by R4? So R1 by R2 is equals to R3 by R4. R1 is x. Capital X they have considered. So this x is different to what I have taken. Capital X by R2 they have given 1, I guess. 1 is equals to R3. So R3 is rho length of the element. Do I know the length of the element? Okay, length of the element, let's take dx. If I take only for element, dx by area, pi r square. If I take only this element, people, this element, if I take, I want to calculate the resistance only for this one, then I'll be putting the limits and getting the total resistance. And here, in this one, I'll be going the limits from 0 to 0.5 meters divided by rho dx by pi r square 0 to 0.5. Rho and pi would be cancelled. And do I know the dx relation? Yes, sir. Dx you can write as dr 1000 by 8 dr. So 1000 by 8 dr by r square going from 0 to 0.5 divided by 1000 by 8 dr by r square going from. One more thing I wanted to say. And if it is going from 0 to 0.5 over here, from 0 to 0.5, the second element is going from 0.5 to 1. So it will be 0.5 to 1. Okay. 1000 by 8 is definitely a constant, would be getting cancelled. And we want total, na? So there will be integration of both sides. So do the integration of both sides, people. 1 by r square will be minus 1 by r, minus minus cancelled. So this will be 1 by r from 0 to 0.5. That will be 1 by r from 0.5 to 1. If you solve it further, that will be 1 upon 0.5 minus 0. So that will be 1 minus 1 upon 0.5, people. And you solve it further, people. After solving, the answer you will be getting is 5 ohm. So if you will be getting R1 or X which I considered is coming to be 5 ohm. Pretty easy question, I guess, people. Let's proceed to the next question. Basic units and measurement question, people. For this, you don't need to even remember the many dimensions. They have given the relation between magnetic field dimension with charge of electron, mass of electron, Planck's constant, and electrostatic force constant, capital K. These all dimensions you have to just put and equate it, people. For dimension of B, how do we calculate? Let me tell you the formulas, then I'm going to write the dimensions directly, so to save our time. Do you really know that formula? One of the easy formula for force is QEB, sin theta or QEB. Here force dimension we know, charge, velocity, definitely we can calculate dimension of magnetic field. You put it over here. Charge is definitely ampere into time, that is current into time. Mass of electron, that is capital M. Planck's constant. How do we calculate dimension of Planck's constant? From the easy formula E equal to h nu. So h is the Planck's constant, nu is the frequency, is the energy. We know really about the energy and frequency. We can calculate the h. How do we calculate K dimension? Easy part. We know the formula F equals to K Q1 Q2 by R square. This K we can write as force into R square by Q1 into Q2. That's how we calculate the dimension of K. From all these formulas, put the dimensions and you can calculate the alpha plus beta plus gamma plus del. So let me write the dimensions for you. I've done it. Dimensions of B is coming to be directly m1t minus 2 a1. Okay, a minus 1. m1 t minus 2 a minus 1 is equals to mass of electron. Definitely, if you solve it further, charge of electron is coming to be 80 to the power alpha, mass to the power beta. Planck's constant I have calculated ml2 t minus 1 to the power gamma. Electrostatic force constant is giving me ml cube a to the power minus 2 t to the power minus 4 del. So if you just solve it further, people, if you solve it further and then you write it, the next equation I'll be getting is m1 t minus 2 a minus 1, and if you write it in terms of m, I'm getting m to the power beta plus gamma plus del, beta plus gamma plus del times of L. If you write L, 2 gamma plus 3 del, 2 gamma plus 3 del t value is coming out to be alpha minus gamma minus 4 del, alpha minus gamma minus 4 del, and times of current, that is ampere, would be giving me alpha minus 2 del. So compare the m, compare the L. What is L over here? L is 0, people. So compare the L, compare the m, compare the t, compare the a, and the final values of alpha, beta, gamma you're getting. Alpha is coming to be 3, beta is coming to be 2, gamma is coming to be minus 3, and del is coming to be 2. And if you add these values, you are getting 4, people. So addition of this is coming to be equals to 4. This question just to check your basic patience about dimension analysis. Easy question. Let's proceed to the next question. In question number 5, if you can see that, the diagram they have given, light is incidenting from this height. This is h height, people, okay, from here to here. This h height also they have mentioned, it is incidenting from here. This is air. Then again, first refractive index layer, second refractive index again there's a layer. This much thickness air again repeating, with the same 2 thickness repeating, again air is repeating. So this slab along with air, this section is getting repeated n times. And they are saying that it is going inside like this, and again it is coming out from here. So what is this length? Initially from where it is incidenting to the point where it is exiting, this length they wanted to ask people. N units are there, what is the value of n they want to ask? And then I guess L also mentioned. So we'll be L, okay, they have given L by 8 by root 3 centimeters. So we have to calculate and how many number of times this section is getting repeated. That's what mean by small n. So here I have made some diagram for you. In first diagram, can you see from H it is incidenting at an angle theta. Can you see, people? So definitely they have mentioned this angle 60 degree to us. So this is air going into first medium. So how much it is going? People, definitely this is air going into first medium of refractive index mu1. Mu1 they have mentioned as root 3 by 2, and that's root 3. So it is mu1 is definitely given as root of 3 by 2, and this is root 3. So can you use the basic Snell's law? That is sin I. For this one, if you use, people, into refractive index over equal to sin r, that is sin theta they have mentioned, sin theta into refractive index root 3 by 2. Sin 60 root 3 by 2 to root 2 is coming, so sin theta is coming 1 by root 2. So theta would be 45 degree. So this angle would be 45 people. So by similarity, this angle will be 45 degree as well. Now this will be the first medium, this will be second medium. So sin I, let's using for this section now, between first slab and second slab. Sin 45 into first refractive index, that is root of 3 by 2 is equals to second refractive index is root 3 into sin theta 2 they have mentioned. So let it be root 3 and root 3 is cancelled. 1 by root 2 would be 2, and it will be coming out to be like sin theta 2 is coming out to be 1 by 2. 30 degree. So this will be 30. So this will be 30 degree as well. So this only for one combination. If we calculate the total length, let this be first, that it will be second and third. If we calculate every of these lengths, then we can calculate the first kind of distance the first section can make us travel. So what this is, for first this is H1060, so this is H1060. This will be T1045. So D they have mentioned, no? Thickness is D, root 3 minus 1 by 2. So this will be D1045. And this section will be D1030. Clear to all, people? And if you solve it further, I guess what's the total length? H1060, D1045, D1030. So if you write H1060 plus D1045 plus D1030. H they have mentioned, people, in the question. H is 1 by 3 centimeter. 1060 is root 3. D they have mentioned root 3 minus 1 by 2. We take common 1045. 1045 is 1 plus 1030, that is 1 by root 3. This is the only first derivation getting provided, and the value which is coming out to solving is 4 root 3 by 6. Okay, let's see the diagram again. So when it is, let's say, going in and coming out, this much length is 4 root 3 by 6. That's what I have calculated, 4 root 3 by 6. Can you see? So first section is giving you 4 root 3 by 6 value. That's 4 root 3 by 6. Then again going into air, first element, second air, again element, air, first second element. So let's say this is getting repeated n times. So only first section of air and 2 slabs are giving me this much. So n times, so total this would be equals to n times of given by single section, that is 4 root 3 by 6, and this value of L they have mentioned in the question is 8 by root 3. 8 by root 3. So n would be coming out to be 12 by 3, 4. If you solve it, you get the n value to be equal to 4 people. I hope so. These 5 questions were clear to all, and questions were very easy about it. So now we're going to proceed with the next questions.
Question 6 is, a charge Q is surrounded by a closed surface consisting of an inverted cone of height small h and base radius capital R and a hemisphere of radius capital R as shown in figure. The electric flux through the conical surface is NQ by 6 epsilon naught. In SI units, the value of small n is. So we have to find value of small n. Okay. So figure is given. You can see here. In this figure, this is charge, this is hemisphere, and this is inverted cone. So this charge is surrounded by this complete, right? By this hemisphere and by this inverted cone, right? We know that how can we find flux? We know that by the Gauss law, we can write flux phi net through any closed surface is Q enclosed divided by epsilon naught, right? You can see here this is completely closed surface, right? And Q enclosed is Q. So this is net flux, right? You can see here, you can divide this net flux like this, flux associated with hemisphere plus flux associated with the cone is equal to Q upon epsilon naught, right? If you think about this situation, so you can see here, these are field lines, right, passing through this hemisphere as well as from this cone, right? This is the net flux. So half of this net flux is passing from hemisphere and remaining flux is passing through cone. So you can directly write flux passing through this cone is half of the total flux, and total flux is Q upon epsilon naught, right? So half of Q upon epsilon naught is Q upon 2 epsilon naught. So this is the value of flux passing through this cone, right? So you can equate, this is given, NQ divided by 6 epsilon naught is equal to Q upon 2 epsilon naught, right? So epsilon naught cancel, Q cancel 3 times, so N is equal to 3, okay? So the value of N is 3. So answer for this question is 3. Question number 7 is, on a frictionless horizontal plane, a bob of mass m is equal to 0.1 kg is attached to a spring with natural length L0 and L0 is 0.1 meter, okay? So we can draw the situation. Situation is like this. This is spring, right? And this bob of mass m is attached with the spring, right? Natural length of the spring is given, that is 0.1 meter. This is L0, 0.1 meter, right? And mass of this bob is 0.1 kilogram. The spring constant is K1. K1 is 0.009 Newton per meter. When the length of a spring L is greater than L0, it is given. The spring constant is K1 when L is greater than L0, means length of the spring is greater than its natural length, means this is the situation of extension. So let's suppose if this is the condition, right? If this is the extension, so in that case, spring constant is K1, right? In this case, right? And is K2 is equal to 0.016 Newton per meter when L is less than L0, means this is the condition of compression. So when this bob is moving in this direction, at that time spring constant is now changed, that is K2. It is given in the question, okay? Initially the bob is released from L is equal to 0.15 meter, okay? Assume that Hooke's law remains valid, okay? Hooke's law is valid in this throughout the motion. If the time period of full oscillation is t is equal to n pi second, then the integer closest to n is. So we have to find integer closest to n, okay? So now see what is happening in the question. See, this is spring, right, and small m mass bob, right. Initially the bob is released from L is equal to 0.15 meter. L is from complete length. Okay, so we are releasing this bob, right. This complete distance is 0.15 meter, right. Natural length of this spring is 0.1 meter. So this extension you can write, this is 0.05 meter, right. So at t is equal to 0, right, we are releasing this. So you know that due to spring force it will go in this direction, right. At this time spring constant is K1, it is given, and value of K1 is 0.009. Then it will come to the mean position, then spring will compress, right, it will move here. In that time this amplitude is different. Why it is different? Because at the time of compression spring constant is now changed. It is not K, it is not K1, it is now K2. Okay, so this is the position of bob. So in that time spring constant is K2, and K2 is given 0.016 Newton per meter and Newton per meter, right. You can see here, let's suppose spring constant of this spring is K, only K, it is not changing. So I think you all know time period of oscillation is, this is the formula, m by K. K is spring constant if K is constant, right. This is the time period. Okay, mean to extreme, extreme to mean, mean to extreme, then extreme to mean. This is complete time. In that case what is happening? You can consider this part as a half part of the SHM, or right, and this part also half part of the SHM, right. Is that clear? Why? Because in this case what is happening, we are releasing this block, right, this bob. So this bob is moving towards its mean position, right, then moving towards its extreme position here K2, and it is returning, right. So this part, this oscillation is half of total oscillation, because in complete oscillation this bob is moving mean to extreme, extreme to mean, mean to extreme, and extreme to mean, right. So you can consider this is the half of the half part of the SHM, right. So if time period of complete SHM is, let's suppose T2, so for this half part of SHM, because this bob is moving from mean position to extreme, extreme to mean, right, with K2. So you can consider this time period, let's say T2 for the complete SHM. For this SHM it is T2 by 2, and similarly for this half part time is, let's suppose for complete part time is T1, so for half part you can write T1 by 2. So this is your complete time period, right. So you can see here T is T1 by 2 and this is T2 by 2, and you know that T is 2 pi under root m by K, right. So you can write 2 pi under root m by not K, K1, because spring constant is different for this condition, different for this condition. Okay, 1 by 2 I am taking common, plus 2 pi under root m by, this is K2, right. Then you can take 2 pi common, 2 pi divided by 2 and under root m by K1 plus under root m by K2, right. This two cancel. So T is equal to pi, m is under root 0.1, K1 is given, that is 0.009. So 0.009 plus under root 0.1 and K2 is 0.016, 0.016, right. Is that clear? Now on solving, see, this is T is equal to pi, this is 0.09 and under root, so you can write 1 upon 0.3 plus 1 upon this is 0.4, right. and T is equal to pi. LCM is 0.12. This is 0.4 plus 0.3, right? So T is pi 0.7 divided by 0.12, right? Okay, so when you solve this, you will get 5.83 times pi, right? So we have to find nearest integer. So nearest integer to this is 6. So your time period is 6 pi. So for this question, answer is 6. Question number 8 is an object and a concave mirror of focal length f is equal to 10 centimeter. Both move along the principal axis of the mirror with constant speed. Okay, the object moves with the speed v0. V0 is 15 centimeter per second towards the mirror. Okay, so this is the speed of the object with respect to, it is given with respect to laboratory frame, means with respect to ground. The distance between the object and the mirror at a given moment is denoted by u, and u is 30 centimeter. The speed of mirror Vm is such that the image is instantaneously at rest with respect to laboratory frame, means speed of image at that instant with respect to ground frame is 0. It is given in the question, right? So what we have to find, it is given the object forms a real image. The magnitude of Vm is in centimeter per second. So we have to find Vm in centimeter per second. So you can see here, first of all, you know that focal length of this concave mirror is given, and by sign convention you can write minus 10 centimeter, right? And u is minus 30 centimeter, right? We have to find velocity of mirror. So first find magnification. So we know that magnification is f upon f minus u, right? So f is minus 10 minus u is minus 30, right, is equal to minus 10 divided by minus 10 plus 30, right? So this is minus 10 by 20, so minus 1 by 2. This is your magnification, right? And we know what is the formula to calculate a velocity in a spherical mirror. We know that this is the relation, velocity of image with respect to mirror is equal to minus times m square velocity of object with respect to mirror. This is the basic formula, okay? So we can write Vi minus Vm is equal to minus m square. This is Vo minus Vm, right? Vi is velocity of image with respect to ground or with respect to laboratory frame. These all are velocities from ground frame. So velocity of image at that instant is 0 and velocity of mirror is unknown, and magnification is minus 1 by 2. So minus 1 by 2 square. Velocity of object is given 15 centimeter and object is moving towards the mirror. So positive 15 minus Vm, right? So minus Vm is equal to minus 1 by 4, 15 minus Vm, right? You can see here, this is minus 4 Vm is equal to 15 minus, okay, this is minus 15 and this is plus Vm, right? So now this is minus 5 Vm is equal to minus 15, minus minus cancel. So Vm is equal to 3 centimeter per second. So for this question, answer is 3 centimeter per second.
So the next question is, in the figure, the inner region A represents a sphere of radius Ra equal to 1, within which the electrostatic charge density varies with the radial distance r from the center as rho A is Kr. So charge density in the inner sphere, it is given by Kr. okay, where K is the positive, K greater than 0. In the spherical shell B of outer radius RB, electrostatic charge density varies as 2K by R. Assume that the dimensions are taken care of, all physical quantities are in their SI unit. So, these are the options given to us. Let us see. See, in every option you are given different value of RB, and corresponding to them you have different parameters, electric field, potential and everything. So, this is 1 meter, I mean this is 1, it is given in SI unit only, so it is 1 meter and RB is there. First option is, if RB is this value under root 3 by 2, it is greater than 1, obviously RB is greater than 1, right. Then the electric field is 0 everywhere outside B. So, for option 1, you didn't even need to solve anything. How? Because see, it is given that rho A is equal to Kr and K is positive, which means this is positive charge, okay. And outer sphere also, it is given to be 2K by R, means this is also positive. And whatever point you are taking, okay, what it is asking, everywhere outside B. If you take any point and you draw the Gaussian surface, you will find that Q enclosed by epsilon naught, this is never going to be 0. This is not going to be 0, this is positive because K is greater than 0. So, you don't even need to solve anything and you can say that option A is wrong. Just noticing the value of K because it is positive. Then first let us find the total charge of the configuration. Okay, how to find total charge of the configuration? So, you can see here let's call it Q1 and let's call it Q2. So, at a distance R, we are considering one thin shell, okay, at a distance R, we will consider one thin shell, clearer diagram. Of width dr. So, we know the charge density here. Charge density is given to be how much? It is given to be Kr, right? Rho A is given to be Kr. So, dq will be equal to, dq can be written as volume 4 pi r square dr into density, which is Kr, and if you integrate it from 0 to 1, because the radius of inner sphere is 1. So, you will get Q1, okay, you will get the value of Q1. For Q2, you take sphere at a distance r greater than 1, okay, and thin shell, we are taking thin shell dr. So, volume dV, it will be 4 pi r square dr, same thing. And now the rho 2 is given to be, rho 2 in this case is given to be how much? 2K by R, rho 2 is 2K by R, right, and you have to integrate it from 1 to RB, and when you do this integration, you will get the value of Q2, this is Q2. So, same calculation is being done over here, okay. Q1 is this, it comes out to be pi k, and Q2 comes out to be 4 pi k r square minus 1. So, Q net, which is Q1 plus Q2, will come out to be pi k 4 r square minus 3. So, Q net is given to be pi k 4 r square minus 3, okay. Now, from here also you can see that r is greater than 1, okay, because it is the radius of outer shell. So, if r is greater than 1, this is RB actually, it is greater than 1, this value can never be negative nor be 0. So, there is no chance that electric field can be 0, okay, outside. Now, moving on to the next option, if RB is 3 by 2, then the electric potential, okay, let us first discuss this total charge because we just calculated. If RB equal to 2, you put RB equal to 2, this will come out to be pi k, and 4 4s are 16 minus 3, that is 13 pi k, okay, this. So, option C is also incorrect. Let us see option number B, RB is 3 by 2, then the electric potential just outside B is K by epsilon naught. What is electric potential just outside B? KQ by R. So 1 upon 4 pi epsilon naught, pi k 4 r square minus 3 by r. Now you put the value of r. What? It is saying 3 by 2. We'll put the value of r 3 by 2 and then we'll check whether it is coming out to be k by epsilon naught or not. So when you put this value, you get k by epsilon naught. Okay. So this option is also this option is correct. Option D, if RB is 5 by 2, then the magnitude of the electric field just outside B is. We'll do the same thing. KQ by r square, put the value of r. When you put the value of r, you will get this 22k by 25 epsilon naught. And in the option it is given to be how much? In the option it is given to be 13 pi k by epsilon naught, which is wrong. So option D is also incorrect. So answer would be option number B. Now moving on to the next question. In circuit 1 and circuit 2 shown in the figure, R1 is 1 ohm, R2 is 2 ohm, R3 is 3 ohm. So 1, 2, 3 and this is R1 by 2, which means half. Correct? P1 and P2 are the power dissipation in circuit 1 and circuit 2 when the switch S1 and S2 are open. So S1 and S2, with S1 and S2 open, the power dissipation is P1 and P2. And when the switches S1 and S2 are in open condition respectively, okay, this was for the first one. Q1 and Q2 are the power dissipations in circuit 1 and 2 when the switches S1 and S2 are in closed condition. So when you will close this S1, S2, Q1 and Q2 represent power dissipation in that situation. So you have to select the correct alternative. First is when a voltage source of 6 volt is connected across A and B in both circuit, P1 is less than V2. So first of all, switch is open. So if switch is open, what is the equivalent resistance? We are not asked power dissipated in a particular resistor. We are asked overall power dissipation. So we can find R equivalent and our task is done, right? So with S1 open, what will be R equivalent? This circuit will be, R1 will be here and it will be in series with this combination. So I hope you will be able to find these two are in series, then parallel, and then these two will be in series. So equivalent capacitance in this situation comes out to be 16 by 11. Okay. And similarly for the second case, this is R2, S2 is open. Okay. So these three are in parallel. So it comes out to be 6 by 11 ohm. Now you see it is saying that about P1 and P2. It is saying that if a 6 volt battery is connected, we are asked about the power dissipation. We know that power is equal to V square by R. If constant voltage is there, then power is inversely proportional to resistance. Okay, if constant voltage source is there, power is inversely proportional to what? Resistance. So whoever resistance is less, the power dissipation will be more. So resistance is less in which case? This is less. RC2 is less, so means P2 will be more. P2 is more than P1, so option A is correct. Okay. Moving on to the next one. When a constant current source of 2 ampere is connected across A and B in both circuits, P1 greater than P2. Now we are providing constant current source. So for constant current source, power dissipation I square R means power is proportional to R. Okay, R equivalent again because we are talking about the power dissipation in complete circuit. Okay, so it is proportional to R. So obviously P1 will be greater than P2 because R1 here is greater than R2. C option. When a voltage source of 6 volt is connected across A and B, Q1 and P1. Now we are comparing Q1 and P1. So for Q1 we need, Q1 is the second situation. So Q1 we need this resistance 5 by 11 ohm, which is again, how did we get that resistance? By closing the switch. Okay, when you close the switch, this will be short circuited and that will come out to be 5 by 11 ohm. And for R2 as well, in the second situation, if you close this, this will also be in parallel with these combinations. So you have one value of resistance here itself. So you have R1, R2 divided by R1 by R2. By that you can find. So yes, It is saying when a voltage source of 6 volt is connected across A and B circuit Q1 and P1. Voltage source is there, means power is inversely proportional to R. So let's say which resistance is less. One is this 16 by 11 and one is 5 by 11. 5 by 11 is less. So Q1 will be greater than P1. So Q1 is greater than P1. So option C is also correct. Option D also constant current source again. So constant current means proportional to R. So Q1 is given to be 5 by 11 and this is 1 by 2. So since this is bigger, right? So if this is bigger, then Q2 will be bigger, means Q2 will be greater than Q1. So this option is wrong. So your answer is ABC. ABC. Fine. So the next question is, a bubble has surface tension S. The ideal gas inside the bubble has ratio of specific heat 5 by 3. Bubble is exposed to the atmosphere and it always retains its spherical shape. When the atmospheric pressure is PA1, so the radius of bubble is found to be R1 and corresponding temperature of the enclosed gas is T1. And when pressure, atmospheric pressure is PA2, radius is R2 and the temperature inside the gas is T2. So we have to select the alternative, correct alternative. First it is asking if the surface of the bubble is a perfect heat insulator. Now when I say that surface is perfect heat insulator, this means adiabatic process, right? It means adiabatic. So we can say that first of all, this is a bubble. Okay, let's say pressure inside the bubble, pressure of a gas inside the bubble is P. So we can say that P gas will be equal to PA1 plus 4S by R1. Correct? Similarly, we can write pressure of the gas inside the bubble in second case as well. Okay. Now our process is adiabatic, and what do we want to do is we want to relate radius and pressure. So basically pressure and volume. So we know that for adiabatic process PV raised to the power gamma is constant, right? So we can write P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma. So what is P1? P1 is PA1 plus 4S by R1 and V1 is given by 4 by 3 pi R1 cube, correct? Raised to the power 5 by 3. Gamma is given to be 5 by 3. So it will be 5 by 3. This is equal to P2, which is given by PA2 plus 4S by R2 into 4 by 3 pi R2 cube raised to the power 5 by 3. Okay, so what you are going to get is R1 by R2 raised to the power 5 will be given by, in this case, this 3 and 3 will get cancelled out. It will come out to be PA2 plus 4S R2 and here it is given 2S. So because of this, this option is wrong. Okay. Moving on to the next option, if the surface of the bubble is a perfect heat insulator, so again indicating adiabatic process, okay, then the total internal energy of the bubble including its surface energy does not change with the external atmospheric pressure. So see, when external atmospheric pressure, when we talk about, when it will change, what will happen? It can exert some force and that will change the volume, okay, that can change the radius, volume. So delta U plus work done will be 0 and adiabatic process will not ensure that work done is 0 in this case. So if this external atmospheric pressure, due to this atmospheric pressure, if any work is done on the gas, then definitely internal energy will also change and hence this option is also wrong. Okay, it is saying that the total internal energy of the bubble including its surface energy does not change. The answer is it may change, okay, depending on the atmospheric pressure. If the surface of the bubble is a perfect heat conductor, now here it is saying perfect heat conductor. So adiabatic process is not there. Okay, and what is the meaning of perfect heat conductor? It means that inside temperature will be equal to outside temperature because it will conduct the heat perfectly and the change in atmospheric temperature is negligible. Now the second statement is change in temperature is negligible, which means delta T0. Inside also, because the temperature that is outside is the same temperature which is inside. So we can say that it is isothermal process. Then you have to tell this thing. So for isothermal process, this is going to be isothermal process. P1 V1 will be equal to P2 V2. Correct? So P1 in this case will be P1 V1, and here we will have P2 V2. So you can see P1 by this R1 by R2 cube in this case will be equal to PA2 plus 4S R2 and PA1 plus 4S R1. So you will get option C as correct. Okay, moving on to the next option. If the surface of the bubble is a perfect heat insulator, then now in this case also we are talking about adiabatic process, and we have to relate temperature with pressure. So we can say that PV raised to the power gamma is constant. Okay, which means V can be replaced by nRT by P. So you will get P 1 minus gamma and T gamma. This is constant. Okay, so when you will apply this condition here, you will get pressure is again PA1 plus 4S by R1 raised to the power 1 minus 5 by 3, which is minus 2 by 3. And here it is T1, okay, T1 raised to the power 5 by 3, correct? It's T raised to the power gamma will be equal to PA2 plus 4S by R2 raised to the power minus 2 by 3, and here you will have T2 raised to the power 5 by 3. So we have to find T2 by T1. So T2 by T1 means T2 by T1 raised to the power 5 by 3, or on taking cube of both the side you will get here 5, and here you will get PA2 plus 4S by R2 divided by PA1 plus 4S by R1 square. So let's see, let's match the option. Okay, here it is T2 by T1 raised to the power 5 by 2 is this. Okay, so we were getting 4S by R2 square here, we were getting square. So this square, this will be square, and if it will come down, it will become here 5 by 2. So this option is also correct. In that situation, we were getting T2 by T1 raised to the power 5 is equal to this whole square. So it means T2 by T1 raised to the power 5 by 2 equal to this. So option D is also correct. So answer for this question will be CD. I hope this is clear.
So now let's move on to question number 12, which is saying that a disk of radius r with uniform positive charge density sigma is placed on the xy plane with its center at the origin. The Coulomb potential along the z-axis is given by this function. The potential as a function of z is given to us, and a particle of positive charge q is placed initially at rest at a point on the z-axis with z equal to z0, and given that z0 is greater than 0. So in addition to the Coulomb force, the particle experiences a vertical force given by F is equals to minus c k cap. That means the force is acting in the negative z direction and its magnitude is equals to c, where c is greater than 0, and one relation is also given that beta is equals to 2c epsilon naught divided by q sigma. So basically it's just a twist. Basically the value of c is given to you in this form. If you will shift the values in LHS and RHS, so you will get the value of c, which is nothing but the force given to you. Okay, so it's asking that which of the following statements is or are correct. So basically, if you will see at the options, you are provided with the values of beta and z0, and you have to check that whether this particle will reach the origin or not. Okay, so basically what we will do over here, we will use the work energy theorem. So work done by the electric force plus the work done by the external agent we are considering this force. Okay, so work done by electric force plus work done by the external force will be equal to the change in kinetic energy. Okay, and work done by electric force will be nothing but charge into the potential difference. Okay, so the charge is q and the potential difference is Vi minus Vf. Okay, so let's put the values, like the V initial is nothing but when the particle was at position Z0. Okay, so put Z equal to Z0 in this expression, so you will get, and multiply Q with this expression, so we will get Q into Vi. So it will be Q sigma by 2 epsilon naught and this expression, okay, minus Q into V final. What is V final? The potential at origin, okay, when the particle will reach origin. Okay, so when you will put Z equal to 0, so we will get under root of R square. So basically it will become R. So sigma into R upon 2 epsilon naught into Q, this Q, okay, plus work done by external agent. The force is acting in the negative Z axis, that means towards origin. Like if this is our origin, this is the XY plane and this is the Y axis. So particle is at the positive Z axis currently, and the force is acting towards origin, okay, and the displacement is also towards the origin. So force will be nothing, the work done will be nothing but force, which is C, into the displacement, which is Z dot. Basically it was initially at Z0 and finally it will be at origin. So the displacement it moved is Z0 if we are considering that it has moved to origin. That would be equal to final kinetic energy minus initial kinetic energy, and initial kinetic energy is 0 as it is given to you in the question that charge Q is placed initially at rest. Okay, now what we have to do now, the value of C is given to you in the question itself, that beta equal to 2C epsilon naught by Q sigma. Okay, so we calculated the value of C. That was just to increase the calculation time. That was given in the paper just to increase your calculation time and just to confuse you. Okay, so just put the value of C in this expression. Now we will have to check for all the 4 options. What we have to do is we have to put the value of beta and Z0 in this expression and check whether this final kinetic energy is coming out to be positive or negative. If it is coming positive, then yes, the particle will reach the origin, and if it is coming out to be negative, then no, the particle will not reach the origin. Okay, so substitute the beta and Z, calculate kinetic energy at Z equal to 0, and if the kinetic energy is positive, then particle will reach at origin, and if it is negative, then the particle will not reach at origin. Okay, so according to this, the correct options will be A, C and D. Okay, so when you will check for the value beta equal to 1 by 4, you will get kinetic energy as positive. So yes, the particle will reach the origin. And for this third option, the kinetic energy will come out to be negative. So the particle is not able to reach the origin, so it will return back. Okay, because the Coulombic repulsion, because of this charged disk, will dominate and it will again reach to its initial position. It will. Okay, so and for D, this for beta greater than 1, Z0 greater than 0, the particle always reaches the origin, because the kinetic energy final will always come out positive if Z0 is greater than 0 and beta is greater than 1. Okay, that's great. So now let's move on to the next question, which is question number 13. A double slit setup is shown in the figure. The figure is on the next slide. So one of the slits is in medium 2 of refractive index N2, and other slit is at the interference of the medium with another medium 1 of refractive index N1. The line joining the slits is perpendicular to the interface and the distance between the slits is d. The slit widths are much smaller than d, and a monochromatic parallel beam of light is incident on the slits from the medium 1. A detector is placed in medium 2 at a large distance from the slits and at an angle theta from the line joining them, so that theta equals the angle of refraction. This is very much important. Theta equals the angle of refraction for the beam, and consider 2 approximately parallel rays from the slits received by the detector. So here is the diagram that 2 parallel rays were coming from this, and here is our detector. Okay, so according to the options, they are asking about the phase difference, and all the options are moving around the phase difference. That phase difference is dependent on which factor? Is it dependent on this? Like what will be the type of interference? Will it be constructive or destructive? So it will also be determined by the phase difference itself, right? So let's see the phase differences. That this ray is coming like this, and till this point they were parallel to each other. But what happened, that in the time this first ray covered this distance, this second ray has moved this much distance in second medium. Okay, and after that again they became parallel. So whatever the phase difference between the rays is all about due to the difference in these paths. Okay, like by the time this first ray moved this one, the second ray moved this one, this much in the second medium, right? So this is what creating the path difference between them. So if we will calculate the difference between these paths, like let it be A1 and let it be B, B1. So if we will be able to calculate the difference between the paths AA1 and BB1, then we'll be able to solve this optical path difference, right? So if you will see this triangle, let's work on calculating the difference between the paths, right? So if you will consider this triangle, so you will be able to see that this is theta and this is D. So this length will be equal to D tan theta. This length will be equal to D tan theta. And I can say that AA1, since this is theta, so this angle will be 90 minus theta. And this length AA1 will be D tan theta cos of 90 minus theta. That means I can say it will be D tan theta sin theta. Like you can solve this much amount of geometry by yourself also, right? This is d tan theta and this is 90 minus theta. So d tan theta cos of 90 minus theta, that means sin theta. And since we are talking about optical path difference, so I'll have to multiply it with the refractive index also. And since this distance is in medium n2, so this will be n2 into d tan theta sin theta. Now let's calculate this distance BB1. So BB1 is nothing but this is d tan theta and this angle is alpha. So this is the hypotenuse of this triangle. This d tan theta is the hypotenuse. Okay. So this length will be nothing but d tan theta sin theta. Okay. Sorry, sin alpha. This angle is alpha. So it will be sin alpha of d tan theta. This is d tan theta. So this length will be d tan theta sin alpha. And since it is in medium of refractive index n1, so we'll multiply it with n1. Now we have to see the difference between these paths. That will ultimately give us the optical path difference. So it will be nothing but this BB1 minus AA1. So it's written over here N1 into d tan theta sin alpha minus N2 d tan theta into sin theta. Okay, now if you will take d tan theta as common, so we will be remaining with N1 sin alpha minus N2 sin theta. Okay, and according to Snell's law, if you will check for any of the ray, that refractive index of the first medium, which is n1, angle of incidence is alpha, so n1 sin alpha will be equal to refractive index of the second medium into sine of angle of refraction, which is theta. Okay, so it will be n1 sin alpha equal to n2 sin theta according to Snell's law, right? So that's what written over here. So I can say that since n1 sin alpha is equal to n2 sin theta, and here's the subtraction of them, so it will become 0. That's why the optical path difference over here becomes 0, and since the optical path difference is 0, so I must say that the phase difference will also be equal to 0. Okay, so the phase difference for both the rays is 0. That means this AA1 and BB1, they are equal. Okay, now let's check for the options that phase difference between the two rays is independent of D. Yes, it is independent because it's 0. So option number 1 is correct. Now, the two rays interfere constructively at the detector. Obviously, if the phase difference between them is 0, then they will interfere constructively. Okay, so option number B is again correct one. The phase difference between the two depends on n1. Not at all, it's 0. It doesn't depend on n1, so it's wrong. Similarly, option number D, the phase difference between the two rays vanishes only for certain values of D. No, it vanishes always. So again, option number D is also incorrect. So the correct answer for this question will be option number A and option number B. Now again, I must say that this question is also not at all tough, right? The only thing that you had to do is to calculate the path difference between the rays. Okay, we just use small like certain amount of geometry and like the Snell's law, and that's it. The question is finished. Okay, now let's move on to the next question, which is question number 14, that in the given PV diagram, a monatomic gas of gamma equal to 5/3 is first compressed adiabatically from state A to state B. Then it expands isothermally from state B to state C, and some values of the constants are given which will be helpful to us while calculation. Okay, and these are the very standard questions of thermodynamics in which the graph between pressure and volume are given and you have to find out the work done. Okay, so let's check out the options. That they are saying that the magnitude of the total work done in process A to B and then C is 144 kilojoule. So we'll have to calculate the work done. Okay, so first let's calculate the work done for the process A to B. Okay, so it's given in the question that the process A to B is adiabatic. Okay, and the pressure and volume at the state A is given, volume is given and pressure is given. At point B, pressure is given, but we'll have to calculate the volume. Okay, so we know that for adiabatic process, I can say PV raised to the power gamma remains constant. So for both of the states, I can equate that PA VA raised to the power gamma will be equal to PB VB raised to the power gamma. Pressure at point A is 10 raised to the power 5 Pascal, volume is 0.8, gamma is 5/3. Pressure at point B is 3 into 10 raised to the power 5, okay, and volume at point B, let it be VB. So when you will solve it for VB, so you will face an expression of 1/3 raised to the power 0.6, okay, and it's given to you in the question that 1/3 raised to the power 0.6 is nothing but 0.5. We can take it as approximately equal to 0.5. So when you will solve it, you will get the value of VB that it is 0.4 meter cube, okay. So if we will calculate the work done in the process A to B, since it's an adiabatic process, so the work done will be nothing but delta PV by gamma minus 1. So PAVA minus PBVB upon gamma minus 1. So all the values we already have calculated. PAVA we already have. PBVB we have just calculated right now. Gamma is given in the question. So when you will put the values, we'll get the answer as that work done in the process from A to B is minus 60 kilojoule. So if you will check out for the magnitude of work done, it's 60 kilojoule. Now, since we have to calculate the work done for the process A to B and then B to C. So A to B is done. Now let's calculate it for B to C, and we know that B to C process, this is isothermal process, okay. So the work done for isothermal process is given by nRT ln V2 by V1. That means the final volume and divided by the initial volume. Final state is C and the initial was B. Okay, so it can also be written as PB VB ln Vc by Vb. So just put the values. We know the value of PB. Vb we have calculated while calculating the work done in path AB, okay, and ln Vc by Vb. So just put the values and we'll get the answer as 84 kilojoule. Okay. So since we wanted to calculate the work done from A, B, C, this path, okay. So the work done in the path ABC will be work done in AB plus work done by BC, work done in the path BC, right? So work done in the process AB is minus 60 and work done in the process BC is 84. So the net work done in the process A to B to C is 24 kilojoule. But in the options it is saying that work done will be 144 kilojoule. So it becomes incorrect because the work done is coming out to be different from 144 kilojoule. Okay. Now, looking at the next option, it is saying the magnitude of the work done in the process BC and in the process AB and CA. So since we have solved option number A, so that means we are done with all the options, although it's a multiple correct question, okay. But in the process of solving the option number A, everything is solved. Like the rest, all other options are also solved automatically. Like it was asking about the work done in process B to C, and we have solved that work done in the process BC is coming out to be 84 kilojoule. So yes, option number B is the correct answer. Now let's check it for magnitude of work done in the process A to B. In A to B, the work done was coming out to be minus 60 and its magnitude is 60. So yes, it is talking about the magnitude. So option number C is also correct. Okay. Talking about option number D, the magnitude of the work done in the process C to A is 0. Now let's look for the process C to A. The volume is constant. So the net work done will be 0. So yes, option number D is also the correct one, that the work done in the process C to A is 0. So the correct option for this question are B, C and D. So I hope that's pretty much clear to everybody, and that was the standard question from thermodynamics. Like if you have solved the questions of the modules, then you must be able to crack it in the exam. Okay, so that's great.
What do we have in this question? We have a flat surface of thin uniform disk A and radius R, and that is glued to the horizontal surface. That means this disk is not going anywhere, right? It's a fixed disk. Another thin uniform disk B of mass A and mass M with the same radius R rolls without slipping on the circumference of A as shown in the figure. But they are asking me a flat surface B also lies on the same plane. That means they are on the same plane. The plane is same. Good. The center of mass of B has a fixed angular speed omega about the vertical axis through the center of A. Fine. The angular momentum of B is something like this with the respect to the center. Which of the following values can be for the N? Alright. Pretty big question, but trust me, it's not that difficult. How? See, what is the situation first? We have this disk over here and we have another disk. Now this disk is fixed and this rolls over this disk. How is it rolling? Without slipping, right? It's written, it rolls without slipping. Alright. So that means first condition that I'll apply at this point, that will be whatever the velocity with which this disk will be moving, this point must have omega r equal to this value, so that there is no slipping, right? And the second condition that I'll apply will be the angular momentum. I think you might have studied that whenever we have a situation of CRTM in which the object is rolling as well as moving, translating, so what we do, we observe it from the frame of center of mass, and then we observe the center of mass from the point from which we are observing. Right. So that's what we are going to do over here. Let's look at the solution. So what do we have? Omega for this point. For this point, if I ask you what is the velocity, so you will say that its velocity is nothing more than omega into r, right? So what's the omega for this one? For this one, the omega is omega naught, and for this the omega is omega. We have differentiated this part. All right. So when this disk is rotating, when the disk number A is rotating, in that situation, this will have the omega on with which it is rotating, correct? So due to this value of omega, if I ask you the velocity of this point, what will be your answer? Your answer will be omega, but the center of this disk is at a distance of 2r. This is r and this is r. So if I ask you the velocity of this point, so the velocity will be omega into the distance of this point, which is equal to 2r. So the velocity of this center of mass will be omega into 2r, right? Now, once I've got the velocity of the center of mass of this disk, since there is no slipping at this point, the omega naught r must be in this direction, so that the net speed at that point must be equal to 0. Correct? No slipping condition. So for no slipping condition, this velocity must be omega r, and they must balance one another. So when I'll balance them, omega into 2r is equal to omega naught into r. That means when I'll equate these two situations, these two, then what I'll be getting? Omega into 2r is equal to omega naught into r. So r gets cancelled out. From here, I'll be getting the condition that omega naught is equal to 2 omega. Alright, that means this must be rotating with twice the angular speed of this disk. Fine. Now, since they had asked me to calculate the net angular momentum, so angular momentum will be given as, first I'll observe it from the frame of the center of mass. Secondly, I'll be looking it from the point on which I am observing, right? So how will I write this? That will be written as L naught, that is given as I omega plus m r cross VCM. Okay. This r is also the position of the center of mass. So just simply substitute the values here and get done with this. So I is given, since this is a disk, for disk the moment of inertia passing through its axis is given as mr square by 2. So we wrote mr square by 2 into omega naught. Omega naught is the angular velocity with which that is rotating. So that completes I omega part. Now we have m r cross v. So m mass is given to me as capital M. What about the r of this disk from this point? The radius, the position of the center of mass is 2r. So r will be 2r into, what's about the speed? It's v. So r 2r into v. Right. Now let's substitute the value here. So v was given as omega into 2r. So I'll substitute the value of omega into 2r over here, and I got this value already. So on simplification, I'll be getting 5 mr square omega. So they had asked me n m omega r square. So you can see that the n value that we are getting is 5. So 5 will be my right answer. So option B is correct. In this question, this is a pretty standard question of modern physics. That's why we keep stressing that modern physics, even though it's a kind of easy topic, but there are a lot of questions that are asked, and you will see that it's a pretty, this is very basic question. I think in each and every class, whenever we start modern physics, this type of questions are usually included in our discussion. What do we have here? When a light of a given wavelength is incident on a metallic surface, the minimum potential energy needed to stop the emitted photoelectrons is given to me as 6 volt. Alright, 6 volt in terms of kinetic energy will convert into electronic volt. So in the first situation, it is given by Sc by m lambda is equal to work function plus 6 electron volt. Now what they say, this potential drop to 0.6 volt if another source is used and the wavelength is 4 times. That means Sc by 4 lambda is equal to phi plus 0.6 eV. So now they are asking me what is the wavelength of the first source, and secondly what's the work function. Now you know that you have two equations, two unknown, right? Lambda is one unknown, phi is another unknown. You can easily solve them. If you want, you can take the ratio and then solve for phi. Once you got the value of phi, substitute here. you know the value of H, you know the value of C, put it over here, you will get the answer of lambda as well. In fact, they have taken some mercy on you, they have put the values over here, but I think you should remember the value of HC by lambda, I mean HC by E, right? So in this situation, when we'll put the values over here, so HC by lambda comes out to be 5 plus 6, this comes out to be HC by 4 lambda is equal to 5 plus 0.6. So when we'll take the difference over here, so from here we are getting 5.4 EV, right? So from this, take this ratio, we'll be getting the value of phi as 1.2. Once we get the value of phi over here, we can easily substitute the value of HC and 0.5, this value over here. So from here, we got the value of lambda as 1.72. So on looking at this, lambda is 1.72, that's for the both one, but phi is 1.2 only in the first option. So answer A is correct one for this one. Phi comes out to be 1.2 and lambda comes out to be 1.72. Alright, I mean 2 equation, 2 unknown, pretty standard stuff. Alright, so I think this question was correct of yours. Thank you.
Now let us have a look at question number 17. Okay, I hope you all have done this question. Okay, so this question is basically based on screw gauge. Okay, area of the cross section of a wire is measured using a screw gauge. The pitch of the main scale is given as 0.5 mm. Okay, so this 0.5 mm is what? This is main scale reading. Okay, 1 MSD is basically given to us. Okay. The circular scale has 100 divisions, and for one full rotation of the circular scale, the main scale shifts by 2 divisions. Okay, so what would be the least count in this case? The least counts, see, in one complete main circular scale rotation, what is happening? It is shifting by 2 divisions. Okay, so here least count would be what? 2 times 0.5 divided by 100. Okay, so in this case, least count would be 2 times 0.5 divided by 100. Okay, so the least count will come out as, the least count in this case will come out as 0.01 millimeters. Correct? Okay. So measurement condition, main scale reading and circular scale reading. Okay, this is given to us. 2 arms of gauge touching each other without wire. Okay, so there is if there is no wire. Okay, and when the 2 arms of gauge they are touching each other. Okay, then main scale reading, that is 0. Okay, and circular scale reading, okay, it is 4 divisions. Okay, so what we can conclude from here, that there is a 0 error over here. Okay, and what would be the value of 0 error? Okay, so in this case the value of 0 error will be nothing but 4 times 0.01. Okay, 0.01 is what? Least count. Okay, so this is basically what? 0 error over here. Okay, very nice. Now attempt 1 with wire. Okay, so now when there is a wire between the 2 gauge, okay, when there is a wire between the 2 arms of the gauge, then main scale reading is what? 4 divisions. Okay, and circular scale reading is 20 divisions. Okay, so if we want the reading over here, okay, reading 1, that would be what? Simply 4 times 1 main scale division. Okay, this is what? Main scale reading. Okay, and 20 times least count. Okay, so 20 into 0.01. Okay, but from here we will also have to subtract 0 error. Okay, so minus 0.05. So what do we got? We get 2.16 mm. Correct? Okay. The same can be done for reading 2 also. Okay, so reading 2 will come out as what? 2.12 mm. Okay. Now here what we'll do, we'll take average of them. Okay, so the average would be what? Mean value would be what? 2.14 mm. Okay, and we know that we take this mean value is what? True value. Okay, although it is not true value, we treat it like that. Correct? Okay, so mean absolute error would be what? First of all, if I have to calculate error in this reading, it would be what? True value minus measured value. Okay, that is 2.14 minus 2.16. Okay, that will come out as what? Minus 0.02. But if we have to calculate mean absolute error, then in that case what we do? We take only magnitude of that thing. Okay, only magnitude of error, or we can say modulus of error. So we'll write 0.02 over here. Similarly, error in reading number 2 would be what? Error in reading number 2 would be what? This reading minus this reading, 2.14 minus 2.12, and that will again come out as what? 0.02. Okay, and we will take average of that. Okay, and we will get what? 0.02. Okay, so our final answer would be what? True value, that is 2.14 plus minus error, and error is what? 0.02. Okay, so this was a very basically simple question. Correct? So what would be the correct option? C would be the correct option. Okay, so now let us move on to question number 80 and let us see what it says. Which one of the following options represent the magnetic field B at O? Okay, so this is point O and we have to basically calculate magnetic field due to this arrangement of wire over here. Okay, and this there is current flowing in this wire over here, correct? Okay, so if we carefully look over here, this question is basically formula based question. Okay, so due to this wire, the magnetic field at this point will be equal to 0. Due to this wire, the magnetic field at this point will be equal to 0. And due to this wire, the magnetic field at this point will be equal to 0. Why? Because the line of these wires are passing through this point O. Yes or no? Yes. Okay. Now, the remaining wires, this wire, and this wire. Okay. So, we have to basically calculate magnetic field due to these wires. Okay. So, for this wire, we can simply use the formula. Okay. And you guys must be already knowing the formula. Okay. So, if we have to calculate magnetic field due to this wire, then we know that this angle is what? 45 degree. Correct? So, we simply have to place the value of as 45 degree, theta as 45 degree in the formula, and what will we get? We will get this expression. Talking about the direction of magnetic field due to this wire. See, what do we do for finding the direction of magnetic field? We simply take our right hand, we point our thumb in the direction of current and we curl our fingers. So, our fingers are curling inside the board. So, magnetic field due to this wire at this point, where it will be? It will be inside the board. Okay. Okay. So, this would be the value of that. Talking about this part, okay, and this part. These are basically what? Part of circles, okay, or we can say this is semicircle, and what we can say this is quadrant of a circular arc, correct? Okay, so we know the formula that due to an arc that is carrying current and it is subtending an angle theta, and the magnetic field due to this arc at the center, it is what? Mu naught I divided by 4 pi r into theta. So, simply that formula is used over here, correct? So, for this arc, this expression is written, and for this arc, this expression is written, okay. So, again what we can say, this is basically formula based question, okay. Talking about the direction of magnetic field due to this arc, what we can do? We'll curl our fingers in the direction of current, and the thumb will give us what? Direction of magnetic field at what? This point, correct. And for this, we can perform the same thing, correct. So, this is what the question was, okay. So, this was all about the paper number 1 physics portion, okay. So, thank you everyone.